Okay, so starting Unit 9. In Unit 9, you actually get to make a decision. You're going to gather information, and you're going to decide if the information that you get warrants which type of conclusion. So like you're going to get data back from testing a drug, and you're going to look at the increase or decrease in whatever it is that you're measuring, and you are going to make a decision as to whether you can say if this drug actually makes a difference or if the difference is just caused by chance. So we're looking to see how much of a difference we need to be able to state that the drug is actually effective. And just like with confidence levels, we're going to have a day for proportions and a day for means. Today, we're just laying the groundwork. So this is the basics. Then 9.2 is on proportions and 9.3 is on means. Throughout most of this course, we emphasize the fact that a statistician's most important job is to draw inferences or guesses about populations based on samples taken from that population. So we're going to be gathering sample information, and we're trying to project conclusions for the population based on the sample data that we have. Methods for drawing inferences about a parameter, and your parameter could be a proportion or a mean, are of two types. Either we're going to make a decision concerning the value of the parameter, which is what we're doing in Chapter 9, or you actually estimate the value of the parameter. Well, that's what you did in Chapter 7 when you found intervals. So Chapter 8 was confidence intervals. Chapter 9 are actual tests. A significance test is a formal procedure for using observed data to decide between two competing claims called hypotheses about a parameter like P or mu. The first step is to determine the null hypothesis. You need to be very comfortable with a null hypothesis. Those are the words. This is the symbol. It's not ho. It's not ho. It's H sub O. So little bitty o. Okay. First step is to determine the null hypothesis. The value of a null hypothesis is often historical value, or it's a claim, or it's a product specification. It's kind of like where the bar is set. I just bought a new car and they say I should get 25 miles to the gallon. Well, that's a claim. I just bought a new iPad and they say that I should be able to download 5,000 songs. Product specification. Or claim. That could be either one. In the past, students average in AP statistics average out to be about a 91 historical value. That's where the bar is set. So all of that is the bar. That's your null hypothesis. Now, your alternate hypothesis, which is not ha, that's H sub A, is any hypothesis that differs from the null hypothesis. I'm supposed to get 25 miles per gallon, but I don't think it's getting that. I'm supposed to be able to download 5,000 songs, but so far I have 6,000 songs. An alternate hypothesis is constructed in a way that is to be the one that's going to be accepted or rejected. Okay, so if I reject the null hypothesis, if I prove, that's a strong word. If I don't have enough evidence to say the null hypothesis is true, then I will accept my alternate hypothesis. He is on trial. The claim, the historical value, the product specification, that is what is in the trial box. Okay. If we accept this one, then we're not interested in the alternate. But if we reject this one, then we will accept our alternate. I'm getting less than 25 miles per gallon on my car. I can download more than 5,000 songs on my iPad. Caution. Hypotheses always refer to a population, not a sample. Whew, I'm going to say that again because we're not super awesome at our notation. So let's be crystal clear here. Hypotheses, your null or your alternate, will always refer to a population, not to a sample. Be sure to state H sub O and H sub A in terms of population parameters, so either P or mu. It is never correct to write a hypothesis about a sample statistic like P hat or X bar. So this will never happen. But you can talk about the mothership or the mothership. And this would have some sort of units. We'll call it pounds. This is a proportion. So those would be good for a null or an alternate hypothesis, or these parameters. But you'll never have statistics in a null or an alternate hypothesis. Okay, examples. We want to determine the null and the alternate hypothesis. Okay, here we go. A car manufacturer advertised that its new subcompact models get 47 miles per gallon. That sounds like a claim. Let mu, because this is an average, not a proportion, let mu be the mean of the mileage distribution for these cars. You assume that the dealer will not underrate the car, but you suspect that the mileage might be overrated. So think about it. If I'm selling cars and I think this car gets 47 miles per gallon, I'm not going to be on the safe side and say, well, it's going to get 40 miles per gallon. No, if I'm advertising it, I'm not going to undersell it. If anything, I'm going to stretch it. I'm going to say, well, it gets 55 miles per gallon because I'm trying to sell it. So you think the mileage is overrated. Okay, so here I go. I have H sub O and I have H sub A. Okay, H sub O is the claim. They are claiming, okay, now is this a mu or a P? Well, this is an average, so this is a mu. They are saying that mu equals 47, now guys, units of measurement, miles per gallon. That's the claim. That's where the bar is set. However, you think that that's overrated. So your alternate hypothesis is that mu is less than 47 miles per gallon. I think they're full of crap. Now, one slight problem. You have used mu, but you have not defined what mu is yet. You have not defined your parameter. So I have to come over here and say mu equals. Now remember, this is a parameter. So mu is the true mean, what? Mean MPGs for all of these new subcompact models. New subcompact models. Again, big words. So guys, that is identical from chapter 8. Identical. Define your parameter. Okay, so null, the claim. Alternate, what you think is really going on. Okay, number 2. A company manufactures ball bearings for precision machines. The average diameter of a certain type of a ball bearing. Okay, a ball bearing is like a metal ball. Well, they can be tiny. I guess they could be bigger. But I had a desk chair one time where one of the wheels kind of broke apart, and there were all these silver tiny beads all over my carpet where my chair was. And I was like, what the world? My husband was like, oh, those are the ball bearings that are in there that help it roll around. Like, okay, that was my first introduction to what a ball bearing was. So the average diameter of a certain type of ball bearing should be 6 millimeters. To check that the average diameter is correct, the company formulates a statistical test. Okay, well, I can already see my null. My null hypothesis is that they should be 6 millimeters. So null, alternate. Don't use an equals right there. Okay, use a colon. Don't use a dash. It's going to look like a negative. Use a colon. Okay, now is this mu or is this p? This is a mu because this is not a proportion. This is an average. So mu equals 6 millimeters. Now the alternate. We're not claiming that they're too big. We're not claiming that they're too small. I just want to know if that's right or not. Well, then your alternate is that it's not 6 millimeters. I'm not claiming that it's bigger or that it's smaller. I'm just claiming that, maybe it's not 6 millimeters. So the null is like the default. They're claiming it's supposed to be 6 millimeters. I'm not sure. I'm going to test it. So my alternate is just that it's not 6 millimeters because they didn't say it was too big or too small. Okay. Now I have to define my parameter. The true, and this is a mean. Mean what? Mean diameter of a certain type of ball bearing. I should write that up. Certain type of ball. I can't spell. Bearing. Yeah, pretend that's right. The true mean diameter of a certain type of a ball bearing. Made by this company. Whatever. Okay. A package delivery service claims that it takes an average of 24 hours to send a package from New York to California. Impressive. An independent customer agency is doing a study to test the truth of this claim. Several complaints have led the agency to suspect that the delivery time is longer than 24 hours. Are people going to complain about their package getting there too soon? No. So you've got to have enough maturity and kind of a with-itness, real world knowledge sprinkled in on this. They shouldn't even have to say that second sentence. If no one's going to complain if it's quicker than 24 hours. Okay. Several complaints have led to the agency to suspect that the delivery time is longer than 24 hours. Okay, pause me. Write your null and your alternate and define your parameter, and then hit play. Null, alternate. 24 hours. Make sure you've got your units of measurement. We're claiming that we're suspicious that it takes longer, so greater than 24 hours. Mu is the true mean time it takes a package to get from New York to California. Okay. So now that you know how to build your null and your alternate and define your parameter, now we're going to talk about how you make a decision as to which one you go with. So we're going to talk about a p-value. All right, now let's be crystal clear here. That is a capital P. This capital P does not stand for proportions. Proportions are lowercase p. This capital P does not stand for probability. I don't know why they can't branch out in their letters. Now, I don't know what p-value, what the p in p-value stands for. I don't know. I'm sure it's somewhere that starts with the letter P. So just note, this is a capital P, okay? The idea, and you always call it p-value, the idea of stating a null hypothesis that we want to find evidence against seems odd at first. It may help to think of a criminal trial. The defendant is innocent until proven guilty. That is, the null hypothesis is innocent, is true, and the prosecution must try to find convincing evidence against this hypothesis and in favor of the alternate hypothesis, guilt. In statistic, we use a probability to say how strong the evidence is. Okay, so just to recap, your null is that you're innocent. The alternate is that you're guilty. We assume you're innocent. If I can't come up with enough evidence to say that you're guilty, then I'm sticking with innocent. Now, I can come up with some evidence. I can put you at the scene of the crime. I can give you a motive. But if I can't prove it without a shadow of a doubt, then they're going to say that you're innocent, even if I have some evidence. So, guys, you're going to get some evidence. You've got to decide if it's enough to reject the null hypothesis and accept the alternate hypothesis, to reject that you're innocent and go with that you're guilty. All right. The p-value is a probability. Okay, well, that makes sense as to why it's a p-value. It is a probability, and that's true. So, guys, if p-value is a probability, then that p-value should always be positive and less than 1 because it's a probability. So, one more time, p-value will always be positive and less than 1. It is the probability computed. Assuming H sub O is true, that the statistic p hat or x bar would take on a value as extreme or more extreme than the one actually observed. AKA, it is the probability that the alternate hypothesis would happen just by chance. Okay, so the p-value is the probability that, assuming you're innocent, the crime still happened just by chance. Okay, here's your scenario. I am walking under a ladder, and Miss Hunter is standing beside the ladder. The ladder falls on me and kills me. The p-value is the probability that that ladder falls on me and kills me by chance. Now, did Miss Hunter do it? Did she kick that ladder out and have it fall on me and kill me? That's the alternate. But the p-value is the probability that it happened just by chance. Therefore, Miss Hunter is still innocent. Okay. Small p-values are evidence against H sub O. There's a tiny chance that that ladder is going to kick out on its own, fall on me, and kill me. If there's a small chance that that's going to happen, then that is evidence against H sub O. Now, H sub O here is that Miss Hunter is innocent. So if the p-value of the ladder falling on me and killing me is tiny, like, I don't know, let's say 0.0014. So 0.14% chance that that ladder is going to fall on me and kill me by chance. Well, then that just ups the odds that Miss Hunter did it, that she kicked that ladder out from under me and killed me. Because they say that the observed result is unlikely to occur when H sub O is true, large p-values fail to give convincing evidence against H sub O and in favor of H sub A, because they say that the observed result is likely to occur by chance alone when H sub O is true. So if my p-value is large, let's go 0.34. There's a 34% chance that that ladder could have slipped and fallen on me and killed me all by itself, just randomly. So 34% the chance that that happened. So that is failing to give convincing evidence against H sub O. We are failing to prove that this is false because they're saying that it's likely that it just fell on me. Okay, so a tiny, tiny, tiny p-value is evidence against H sub O. So this is not the probability that Miss Hunter is innocent or guilty. It's the probability that the event happened by chance. And the bigger that number is, the more innocent she gets, the more true H sub O is. In other words, the p-value is the smallest significance level for which we would reject H sub O. Well, that sounds like a rubber stamp sentence right there. In other words, the p-value is the smallest significance level for which we would reject H sub O. The smaller the p-value, the stronger the evidence to reject H sub O. Remember, the smaller the p-value, the smaller the chance that that ladder fell on me by chance, the stronger the evidence is to reject H sub O, and H sub O is that Miss Hunter is innocent. So the smaller the p-value, the more evidence I have to say that Miss Hunter is guilty, to go with H sub A. Okay, now right here at the bottom of this page, there used to be something there, and I do not know if it's in your notes or not, but you need to draw this. Let's see. P-value. Yes, that is the Jesus fish. So draw the Jesus fish. All right, the Jesus fish is a Greek symbol. It is lowercase a. It is called alpha. All right, so we have alpha. All right, now alpha is the dude that says, okay, I will decide. He's like the judge. And alpha's value is set before the problem. So alpha says, okay, bring me all your evidence. wrap that up and find me a p-value. So what you're going to do is you're going to take all your evidence, and then your job is to go get a p-value. Okay, so you have this numerical p-value, whether it's 34% or 0.11% or whatever, you find this p-value. Your alpha, which is usually 5% or 1%, one of the two. You either have a strict judge or a more lenient judge. If your p-value is above that level, so 0.05 or 0.01, then you accept H sub O. That means that p-value is too high. That ladder probably did fall on Miss Patterson and kill her dead. God rest her soul. We'll miss her terribly, but I don't think Miss Hunter did it. I think that ladder just slipped and fell. Or if that p-value is so low, the odds of it happening on its own are so slim, then we reject H sub O. Nope, Miss Hunter is not innocent. She is guilty. She did it. There's too small of a chance that it happened on its own. It had to be Miss Hunter. Okay, so your alpha is the judge. Here's your p-value. It goes all the way up to 1, all the way down to 0. Because remember, your p-value is a percentage. Your alpha comes in here and cuts it at either 5% or 1%, one of the two. I've seen a couple 10%, but they'll set it beforehand. And then you come in here and you decide, is your p-value up here or is your p-value down here? If your p-value is down here, then Miss Hunter's guilty. You reject it. Reject H sub O. That car does not get 47 miles per gallon. That ball bearing is not 6 millimeters. And you accept the alternate. The car does get less than 47 miles per gallon. Those ball bearings are not 6 millimeters. Miss Hunter is guilty. Okay. Here we go. Healthy bones. Calcium is a vital nutrient for healthy bones and teeth. The National Institute of Health, NIH, recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers aren't getting enough calcium. Now, do you see this? Is this true? That is the green light for a test. Is this true? Test this claim. Bring me justification. Okay? So those are words you want to look for. It's not asking for you to find a confidence interval. It's asking for you to make a decision. Yes or no, is this true? All right, it says state the null and the alternate. Okay, here we go. Null, alternate. Calcium is found in healthy bones and teeth. Recommends a calcium intake of 1,300. All right, that's the bar. They need, now this is a mean, not a proportion, so I'm going mu, not p. 1,300 milligrams. That's what they should be getting. However, they are worried that they're not getting enough. So they are proposing that mu is less than 1,300. Okay, now you just done that. So what have you got to do? You got to come over here and you got to define mu. The true mean, because these are means, won't always be means. There will be proportions here in a little bit. The true mean, what? What are we measuring? Calcium intake. For all teenagers. Daily. Let me do daily intake. Again, I'm trying to communicate to the grader that, okay, I'm reading, like I'm processing this information, like I'm responsible, I'm mature, I can figure out, I don't know anything about calcium intake, but I can read and make an educated parameter for this. The true mean calcium daily intake for all teenagers, because it does say per day. All right. Researchers want to perform a test where mu is the true mean daily calcium intake in the population of teenagers. Okay, well, we already defined that. They ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute that the calcium intake for each student. Data analysis reveals that X bar, because this is sample now, is 1198 milligrams and the standard deviation of 411 milligrams. That's a very large standard deviation for a mean of just over 1,000. After checking that conditions were met, independent, random, normal, researchers performed a significant test. Okay, so this is the part you're going to learn in 8.2 and 8.3. Okay, so they've already done it, and shazam, there's your p-value. So it has been placed in your lap. Explain what it would mean for the null hypothesis to be true in this setting, and interpret the p-value in context. Explain what it would mean for the null hypothesis, go look at your null hypothesis, to be true in this setting. Then interpret the p-value in context. All right. I'm going to type instead of write. So here we go. Let's see if I can do this. I can really do this. All right. Explain what it means for the null hypothesis to be true in this setting. Okay, so if H sub O, now I can't write the sub part, so it's going to say ho. If H sub O is true, then the mean daily calcium intake in the population of teenagers is 1,300 milligrams. So they are getting enough calcium on average. Explain what it would mean for the null hypothesis to be true in this setting. Okay, so if H sub O is true, then the mean daily calcium intake in the population of teenagers is 1,300 milligrams. Now notice, I didn't just say mu equals 1,300 milligrams. I'm trying to write it in context for this problem. Okay, now what that means is they were worried about them not getting enough calcium. So this part right here, hold on, nope. This part right here is me putting my Captain Obvious hat on and saying, well, they were worried about them not getting enough calcium, but if H sub O is true, everybody just needs to chill out because they are getting enough calcium. Okay. Now, part B. Here's a beautiful rubber stamp sentence. Interpret the p-value in context. Ooh, that sounds like something that I would ask you to do on an upcoming quiz. Huh. Okay. So, assuming H sub, okay, interpret the p-value. All right, so here's the deal. To interpret the p-value, you have to assume H sub O is true. Okay, so we have to assume Miss Hunter is innocent. We have to assume that you're getting 47 miles per gallon. In this problem, we have to assume that the average calcium intake for teenagers is 1,300 milligrams. You have to assume that H sub O is true, and you have to state that first. So here we go. Assuming that the average calcium daily intake for teenagers is 1,300 milligrams. So assuming that H sub O is true, I don't say assuming H sub O is true, I write assuming that whatever H sub O is true, assuming that that's true, then there is a, okay, now what was your p-value? 0.1404. There is a basically 14% chance that the ladder fell on Miss Patterson and killed her dead by chance. That your particular car didn't get 47 miles per gallon. It got less than that. There's a 14% chance that that H sub A happened by chance. Okay, so there is a 0.1404 probability of getting a sample mean of, okay, now what was our sample mean? Our sample mean was 1198 milligrams or less, because remember our alternate was less than. So of getting that or less just by chance in a random sample of 20 teens. Okay, giving you a chance to write it down. Okay, so the first part, we have to assume that H sub O is true. That's step number one. For interpreting a p-value, assume that H sub O is true. Then there is a, whatever your p-value is, probability. Okay, you are interpreting the p-value, you need to use the p-value. There is a blank probability of getting a sample mean or a sample proportion, depending on the problem, of whatever you got for that sample mean or the sample proportion. And then I added the or less because remember that my mean for my H sub A was mu is less than. If this was a greater than, then down here would say or greater. If it was a not equal to, it would say right here something about being extreme or as extreme, because it doesn't matter which way it goes. Could be greater, could be less. It just needs to be 1198 or more extreme. Okay. Then you have to have the just by chance, because that's the whole point of a p-value, is that it happened just by chance. And then you have to talk about your random sample of the same size. It packs a wallop. This is a big rubber stamp sentence. So practice. Practice. I would almost guarantee you're going to have one of these on the AP exam. So do not use something that I have written as a crutch. Every time you do your homework or take a quiz, take a test, do it on your own, because you've got to be able to write these on your own. Assuming that the average daily calcium intake for teenagers is 1,300 milligrams, assuming H sub O is true, there is a, whatever your p-value is, probability of getting a sample mean or proportion of whatever your sample mean or proportion was, or less, or more than, or as extreme or more, depending on what your H sub A is, just by chance in a random sample of the same size. Okay, practice, practice, practice. Okay. Now, let's make some decisions. Let's be a jury. Okay. So, on the first one, it says fail to reject H sub O, i.e. we're going to accept H sub O. So when Miss Hunter's on trial for killing me, we're going to accept that she's innocent. Well, are we? Accepting that she's innocent really just means that enough information was not presented to convict her. So really, we're just failing to reject it. I don't have enough information to reject H sub O, to reject that she's innocent. They didn't present me with enough information. They kind of put her at the scene, like she kind of had a motive, but I didn't have enough evidence to reject that she's innocent and to go with the fact that she was guilty. So we're not going to say accept H sub O. We're going to say that we're going to fail to reject. So here's what we're going to say. There is not enough evidence in the data to justify a rejection of H sub O. This means that we retain, we keep it with the understanding that we have not proved it to be true beyond all doubt. Some people are still going to think Miss Hunter did it. There was just evidence there. There was just evidence there. Okay? Now, rejecting H sub O. Rejecting H sub O, or failing to accept H sub O. If I reject H sub O, then I say, Miss Hunter did it. She is not innocent. I am rejecting H sub O. There is enough evidence in the data to justify rejecting H sub O. This means that we choose the alternate hypothesis with the understanding that we have not proved H sub A to be true. We just have enough evidence to reject H sub O, so we're going to go with H sub A. So you have to be real careful. And we're gonna write, oh my God, we're gonna write this so many times, like you're gonna know it like the back of your hand. You know how you know the confidence interval statement? I'm 95% confident that my interval from blank to blank captures the true mean whatever of whatever. You're gonna have that kind of, you're gonna be that comfortable with these kinds of sentences by the time we're done. Okay. If your p-value is really, really small, then the probability that the ladder fell on me by chance is tiny. So odds are we're going to reject H sub O. Miss Hunter is innocent? No, I reject that. I have enough convincing evidence for H sub A. If I have a very large p-value, that means that there's a large probability that the ladder just fell on my head and killed me dead by chance. So I'm failing to reject H sub O. I am not saying I'm failing to reject H sub O. So I cannot reject that Miss Hunter's innocent. I do not have enough convincing evidence for H sub A. This is the part I want you to focus on for right now. You're going to write convincing evidence every time you do one of these. When you talk about your evidence, you are gathering evidence as to whether or not you can go with H sub A. So when you talk about your evidence, you need to always put it in terms of H sub A. I have enough convincing evidence for H sub A, therefore I'm rejecting H sub O. I do not have enough convincing evidence for H sub A, therefore I'm sticking with H sub O. But your evidence statement is always about your alternate. Okay, here we go. Let's make some decisions. Let's be a jury here. Better batteries. A company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Like, don't give me wimpy data. Give me good, strong data. Okay? Based on years of experience, the company knows that the regular AAA batteries last for about 30 hours. The company selects a simple random sample of 15, first of all, that's a terrible sample, that's tiny, 15 new batteries, and uses them continuously until they completely drained. The new sample mean lifetime is 33.9 hours. A significance test is performed using the hypothesis. So guys, you can't look at this and say, well, duh, look at it. It's 33.9 hours. Heck yeah, they last longer. You only took a sample of 15 batteries. I need to know if this data is statistically significant, and that's why you are conducting a significance test. You are judge, jury, and convictor. Significance test. All right, here we go. The null is the original. And these are means, right? These are not proportions. These are means because we're talking about average battery life. And remember, your null and your alternate is always in terms of parameters. So since these are means, I'm going to use mu. So normally, and I'm going to use my units of measurement, mu is 30 hours. But we are thinking that the mu is now greater than 30 hours. Notice, I did not use this in my null or my alternate at all. I'm not putting sample information in there. Okay? Now, what I have not done is define my mu, but if I keep reading, they've defined it for me. It says where mu is the true mean lifetime of the new deluxe AAA battery. Then, voila, it gives me a p-value. This is what you will learn how to find in 8.2 and 8.3. You will learn how to find that p-value. Right now, they're giving it to you on a silver platter. Now, that p-value is 7% and some change. Okay, 7% and some change. Now, that p-value's got some teeth to it. Like, that's not tiny. Some of these p-values get microscopic. So here's the question. What conclusion would you make for each of the following significance levels and justify your answer? All right, so here we go. For A, think about this. Remember, alpha, there's my 10%. That's cut. That's alpha. My p-value is 0.07. So my p-value is down here. And when it's down here, we reject H sub O. When your alpha is greater than your p-value, or your p-value is less than your alpha, however you want to think about it. Okay, so here's what I'm going to write. P-value less than alpha, and then I'm going to put what my p-value was, 0.0729, is less than, the bar was set at 10%. That's the judge right there. You know, I'm sorry, you got to be bigger than 10%. Okay, so since my p-value is smaller than my alpha, we reject H sub O. Now think about what that means. I reject H sub O. Go look at what your H sub O is. I reject that the batteries are 30 hours, that last for 30 hours. So that means now I get to go with my alternate hypothesis. Oh, good. Okay, so now we're saying, hey, these batteries are going to last longer. Okay, there's a way that you write these sentences. Ready? We have convincing evidence. Let's say we have enough. We have enough convincing evidence. Let's see if I can spell. Sure. We have enough convincing evidence to conclude. Now remember, I said when you talk about your evidence statement, that statement is always about your alternate hypothesis. So I have enough convincing evidence to conclude. Okay, go look at what your alternate was. Your alternate is that the batteries last longer. So I don't want this in statistical symbols. I want it in words. To conclude that the new AAA batteries last longer than 30 hours. reason, I'm just going to put this on average because you know there's going to be one or two that don't. Okay. So here we go. Let's give it a once over. My alpha was set at 10%. My p-value was less than that. When your p-value falls below your alpha, you reject your H sub O. Okay? So first I'll start with that. We reject H sub O. So I reject that these batteries last 30 hours. You don't have to state that. You just have to state we reject H sub O, which means there was enough evidence, okay, to go with the alternate. So in that in a pretty sentence is going to say we have enough convincing evidence to conclude whatever H sub A, whatever the alternate has proposed. We have enough convincing evidence to conclude that the new AAA batteries last longer than 30 hours on average. Okay. So now, my new judge for part B, alpha is 5%. There's alpha. Now my p-value is 0.0729. That, my friends, is up here. So my p-value is greater than my alpha. 0.0729 is greater than 0.05. Now some of you may think that that is ridiculous that you have to write that. But you know what? You have to communicate that you acknowledge that relationship between those two very important variables. I'm stating that relationship. Then I form my beautiful conclusion. But state the relationship first. Okay. Now, since my p-value is up here, I'm not going to say we accept, like down here is reject H sub O. I'm not going to go up here and write accept H sub O. I'm going to put fail to reject. Because what has just happened is you gave me some evidence, but you didn't give me enough convincing evidence for this judge. This judge, this alpha at 5% said, it's not enough. Now, the 10% alpha that's in blue, he was fine with it. But this red alpha that's a 0.05 ain't having it. So, instead of we reject H sub O, we fail to reject H sub O. I failed to reject that Miss Hunter's innocent. I didn't prove that she was innocent, but I don't have enough information to say that she was guilty. So I'm failing to reject H sub O. We do not have enough convincing evidence to conclude that the new AAA batteries last longer than 30 hours. Exact same sentence, you're just going to put a do not in front of it. We do not have enough, missed a U, convincing evidence to conclude that the new AAA battery lasts longer than 30 hours on average. Now, could I get one or two that last longer than 30 hours? Absolutely. Remember, you had a crappy sample. It's only 15. And guys, sample size is a huge factor in figuring out what your p-value is. So sample size does affect this. So because my p-value was above alpha, then I failed to reject H sub O. I do not have enough convincing evidence to conclude H sub A. So guys, my conclusion is about my H sub O. I rejected him or I failed to reject him. but my evidence sentence is about my H sub A, my alternate. And that's how I want those sentences every single time. Rubber stamp. I reject H sub O. I fail to reject H sub O. I have enough convincing evidence to go with H sub A. I do not have enough convincing evidence to go with H sub A. All right. Last thing we got to talk about are errors. Because you know that there are people who were innocent who were found guilty. You also know that there were people who were not innocent who were not found guilty. So we have errors here. Okay. The most commonly used significance level is alpha equals 0.05, so 5%. But you always need to state your level of significance before the data is produced. Otherwise, a deceptive user of statistics, which is like 50% of all statisticians, might set a significance level after the data has been analyzed in an attempt to manipulate the conclusion. So let's think about this. Go back to the battery problem. If I didn't establish what my alpha was before I started the problem, and I got a p-value of 0.07, then depending on what kind of point I was trying to make, if I'm trying to push the batteries through, then I'm going to say, oh, well, alpha was 0.10. Or if I'm trying to shut the batteries down and say, no, we don't need to change them, then I'm going to say, oh, no, my alpha is 0.05. So you can't pick your alpha after you found your p-value. You have to establish your judge, your alpha, from the beginning. 99% of the problems are going to tell you what your alpha is before you start. If they don't, you set it, and always default to 0.05. But state it at the beginning of your problem. You write your null and your alternate, define your parameter, state your alpha, state your judge. Okay? All right. Type 1 and type 2 errors. When we draw a conclusion from a significance test, we hope our conclusion will be correct, but sometimes it's going to be wrong. There are two types of mistakes we can make. We can reject the null when it's actually true. That's known as a type 1 error. Or we can fail to reject the null when the alternate is actually true, and that's a type 2 error. If we reject H sub O when H sub O is true, that's a type 1 error. If we fail to reject H sub O when H sub A is true, that's a type 2 error. And right now that sounds like gibberish. So here's how I remember it, and I usually like do this thing in the air with my hands, but you can't see me. So let me see if I can do this. Type 1, nope. No, let me do this. H sub O, H sub A. All right, I want you to think about this like floors on a house. This is floor number 1, and this is floor number 2. Okay, a type 1 error is when you go with this. You say this is true, but really this is true. That's a type 1 error. Now, type 1 error means you say H sub O, you say Miss Hunter is innocent, but really H sub O is true. Type 1 error. H sub O is true, but you're rejecting H sub O and you're going with H sub A. So I think of this like the 1 and the 2 as the first floor and the second floor of a house. And this is how you always write. H sub O is always first, and then H sub A is always underneath it. So always think of H sub O as being on the second floor and H sub A being on the first floor. So a type 1 error means you go to the first floor first, and you say that that's true. She is innocent. Those batteries last longer than 30 hours. When actually, the second floor is actually true. Now a type 2 error goes to the second floor first. Type 2 says this is true. H sub O is true, when actually this is really true. And that's what this means too. So you say type 2 error means you say the second floor is true. Well, the second floor is going to be your H sub O. You say that she's innocent when really she was guilty. You say, okay, the batteries only last 30 hours. Okay, but actually they lasted longer. You made a mistake and now you lost out on all this money. You say that the MPGs are that it gets 47 miles per gallon, when actually it gets less than that. So now you've ticked a customer off. A type 1 error is going to say, hey, the batteries last longer than 30 hours, when actually they don't. They last 30 hours. So then you go through and you produce this stuff and you advertise and you put this battery out here, and it doesn't actually last longer. Actually, what's really true is the null, the fact that they were 30 hours. So now you've ticked all these customers off, you're getting bad publicity, and your company's probably going to go down the drain. So not only are we talking about these errors, but we're talking about the consequences of these errors. So, and that's what multiple FRQs I have seen, where you do a full-on test where you have to state your conditions and write your null and your alternate and find your p-value by hand, which you'll learn later, and then draw your conclusion. Then part B says, what would be a type 1 error and what would be the consequences of this error? What would be a type 2 error and what would be the consequences of this error, or the repercussions? Okay, so last thing we're going to do is we're going to talk about potatoes. We're going to talk about repercussions of making a mistake with potatoes. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample, not just the potatoes on the top of the truck. That's a bias sample. That is a convenience sample. So we have to do a good random sample of the potatoes from the shipment. The producer will then perform a significance test using the hypothesis. All right, I say 8%. 8% have blemishes. The alternate, greater than 8%. Okay, and you're going to get into this in 9.2 and 9.3, but your null is always equal to. Your alternate is greater than or less than or not equal to. And we'll talk much more about that in 9.2 and 9.3, but your null is always equal to. So now this is a P. Look, we have our first P today. This is a P because this is a proportion. This is a proportion of the potatoes that have blemishes. I'm not mu anymore. I'm now a P. Lowercase p, not capital P, lowercase p. Then it has to define my parameter. P is the actual proportion or the true proportion of all potatoes with blemishes in a given truckload. Describe a type 1 and a type 2 error in this setting and explain the consequences of each. Which error do you think is more serious? Okay, here's my house. There are the levels on the house. This is level number 1 because it's the first floor. This is level number 2 because it's the second floor. Okay, so a type 1, always Roman numerals. Type 1 error. Type 1 error means you go to the first floor and you buy in. But actually, the second floor is true. Okay, I'm not going to write. I'm just going to talk. You pause me, rewind me, you do what you need to do so that you can write this down. A type 1 error means that you found convincing evidence that the proportion of potatoes with blemishes exceeds 8%. Okay, so I just said in words what H sub A is. Because a type 1 error means I've got enough evidence that I'm going with the first floor, but really the second floor is true. So, one more time, I have found enough convincing evidence to conclude that the proportion of potatoes with blemishes exceeds or is greater than 8%. When actually, so I believe this, but actually this is true. I'm going with level 1, but actually level 2 is true. When actually the blemishes don't exceed 8%. Consequences. Well, I now have a truck and I believe that it has more than 8% blemishes when actually it doesn't. So here's what's going to happen. I'm going to send this truck away and it's actually fine. So I'm costing my supplier money. I'm sending a truckload full of good potatoes back to my supplier and I'm telling him that they're crap when they're really not. So I'm costing my supplier money. I'm also putting a strain on our relationship because I'm saying his potatoes are crap when actually it's a good product. So I could lose his business and have to go find me another potato supplier. Okay. A type 2 error. Okay, type 2 error means you go to the second floor. So I say this is true when really this is true. So I say that level 2 is true. Level 2 is H sub O. That's who's on the second floor. So I think there's enough convincing evidence to conclude that the proportion of potatoes with blemishes is only 8%. When actually it's bigger than that. So what's going to happen? I'm going to let a truckload of bad potatoes in to be processed. I got a truckload of bad potatoes, but I didn't know it because I made a type 2 error. I'm going with level 2, which means I'm saying that H sub O is true, which means they're fine. I'm saying these potatoes are fine when actually they're not. So now I'm bringing all these potatoes in. I'm going to make bad, what are we doing? Are we making chips? Yes, I'm making potato chips. I'm going to make bad potato chips, put them on the shelf. Customers are going to eat them. It's nasty. My reputation as a potato chip producer is now on the line. I'm going to get bad publicity. People aren't going to buy my chip. So that hurts me, the chip maker. Does not hurt the potato man. He gave me a shipment of bad potatoes and I didn't catch it. He just dumped off crappy potatoes on me. And I paid him for it. And then I made a whole crap ton of potato chips, put them on the shelf, and people are going to eat them and they're going to hate my potato chips. It's going to hurt my reputation. I'm going to lose money. Okay, last one, the batteries. That was a mu. Mean was 30 hours. Don't write, just watch. We were claiming that it was greater than 30 hours. Okay, this is level number 1. This is level number 2. Think of a house. Okay, type 1 error. Type 1 error means I think this, but that's really true. Type 1 error. Describe a type 1 error in this setting. Type 1 error would say, I believe that those batteries last longer than 30 hours, when actually they don't. We roll with it, we produce them, we put them on the shelf, customers get them. They think that they're supposed to last longer than 30 hours, and they don't. My company now has a bad reputation. I've lose money. Okay, type 2 error. Type 2 error means I go with level 2. I go with the fact that they only last 30 hours, when actually they last longer than 30 hours. So I go with this one when actually this one is true, but I believe this one. So I say, sir, we did this test. These new batteries only last 30 minutes. They do not last longer than 30 minutes, when actually they do. So this idea stops dead in its tracks. There's money to be made off of these new batteries, and I'm not going to make it because I made an error in my data. I'm telling my CEO, listen, don't move forward with this. The data tells us that these batteries only last 30 hours. You need to stop investigating this, stop producing this, stop running lab tests on this, stop wasting your money. Then Duracell is going to get the same technology, and they're going to run with it, and they're going to make all my profit that I could have made because I made a stupid error. Which one is more serious? In this case, I would say the first one, because the first one is going to damage my reputation. The second one just means there's money to be made and I'm not making it. But it doesn't hurt my reputation as a battery producer. The first error makes me put bad product into the public's hand. And to a company, that's the kiss of death. So, if this interests you, then you need to go to college and you need to major in business and you need to minor in statistics. And you could do this all day long. You would be the CEO's right-hand man because your job would be to go gather data, conduct tests, and report back, what should we do? And there is money to be made because people do not know how to do this. So if you can have that niche, you want to talk about job security and just a business degree versus a business with a statistics degree, your application going to the top of the pile, it makes you so much more marketable. Okay, so we laid the groundwork for tests. I know that was a lot, but again, we're laying the groundwork, so it's a lot of information. In 9.2, we will actually be finding that p-value and then drawing the conclusion and talking about errors and doing our null and our alternate and our conditions, all that wonderful stuff. So, exciting things to come.